Now we are discussing about the fast Fourier transformation. In the fast Fourier transformation, suppose if I have a sequence x of n given by, so same formula we can consider as the last one. So 0.5, then 1, 0.5 and 0. So we got the DFT of the sequence, that is direct DFT. So we have to substitute n different values as well as k different values between 0 to n minus 1. So there we got x of k is 2 minus j and 0 and it is j. Now find this DFT of the given sequence using radix to FFT algorithm. So radix to FFT algorithm we have two types. First one is DIT FFT algorithm and second one is DIF FFT algorithm. Now in terms of DIT FFT algorithm, so time will be decimated. So suppose if you are having a sequence n will be divided as 2 halves, that is n by 2, n by 2. Then again n by 2 will be decimated as n by 4, n by 4. Again n by 2 is decimated as n by 4, n by 4 and so on. So this process will be continuous and depending upon the length of the sequence. Find the DFT of the given sequence using DIT FFT algorithm. Now given sequence solution. The given sequence is x of n, that is 0.5, 1, 0.5 and 0. So let us consider how many samples we have. 4, n is equal to 4. So whenever you have 4, the 4 can be written down as in terms of 2 power, that is 2 power 2. Therefore, the number of stages capital M is equal to 2. For n is equal to 4, we have 2 number of stages. So depending upon this, in terms of direct DFT formula, x of k is equal to summation 0 to n minus 1 x of n e power minus j 2 pi k into small n by capital N. Okay. So here what we are doing, this is equation number 1. Then from equation number 1, if I take a represent omega n power k, so this is called it as twiddle factor. So if we represent twiddle factor before the solution, then it will make the solution of finding the DFT is simple. So e power minus j 2 pi k by n. Now substitute this 2 in equation number 1. Then x of k will be summation n is equal to 0 to n minus 1 x of n omega n power k into n. So this is a formula for finding the DFT using fast Fourier transformation. Now given n is equal to 4, if n is equal to 4, then number of stages is equal to 2 stages. So the name itself, decimation in time. So decimation means division. So we are dividing the entire solution into parts or number of stages. For n is equal to 2, whatever the sequence it is, we have only 2 stages, stage 1 and stage 2. So for stage 1, depending upon which stage it is, we have stage indexes. So stage index represented by small m. For stage 1, the stage index is 1, and for stage 2, the stage index is 2. Now, in order to find out the twiddle factor, what is the k value? So, k is depending upon, so this is called twiddle factor exponent. Twiddle factor exponent. So, depending upon k will be depends on index. The formula for finding the twiddle factor exponent is n into t by 2 power m. So, where n is equal to the length of the sequence, small m is stage indexes depending upon stage 1, stage 2 and so on, and t is equal to also depending upon the stage index. The starting value of t is 0, 1 up to so on, 2 power m minus 1 minus 1. Similarly for stage 2 also. Then for stage 1, the stage index is 1, then t value is 0, 1 up to so on, 2 power m minus 1, that is 1 minus 1 minus 1. So therefore t is equal to 0. If t is equal to 0, if I substitute in the k value, twiddle factor exponent, n value is 4, t value is 0 and index value is 1. So therefore k is equal to 0. If k is equal to 0, we have twiddle factor. That twiddle factor is omega 4 power 0, omega n power k. N already we know that is 4 and k already know that is 0. So if I substitute the same in the formula, e power minus j 2 pi, k value is 0 divided by 4. So e power minus 0. Therefore, using the Euler's formula, cos 0 minus j sin 0, cos 0 value is 1 and sin 0 value is 0. And this is, we can write it down as, for stage 1, we have only one twiddle factor. That twiddle factor is omega 4 power 0, that is equals to 1. Next, for stage 2, similarly we can find it out. M is equal to 2. If M is equal to 2, t value is 2 power 2 minus 1 minus 1. So 2 power 1 minus 1, 2 minus 1 is 1. The t value is starting from 1 and ending with, starting from 0 and ending with 1. If t is equal to 0, then k is equal to 4 into 0 by, so here for second stage, the stage index is 2. Therefore, k is equal to 0. If k is equal to 0, then twiddle factor is omega 4 power 0, that is equals to 1. Now for t is equal to 1, for stage 2, 2 t values we have, therefore 2 k values should be there. If t is equal to 1, the k value is 1. If I substitute in the same value, omega 4 power 1, then omega 4 power 1 is e power minus j 2 pi, k value is 1 divided by 4. So e power minus j pi by 2. Using Euler's formula, cos pi by 2 minus j sin pi by 2. Cos pi by 2 value is 0 and sin pi by 2 value is 1. So therefore, omega 4 power 1 is equal to minus j. So for stage 2, if I write the final statement, I have two twiddle factors, and first twiddle factor is omega 4 power 0, the value is 1, and second twiddle factor omega 4 power 1, the value is minus j. So these are the final statement. For stage 1, only one twiddle factor. For stage 2, two twiddle factors. Now what I am trying to do is, what is the n value? N value is 4. Now I have to draw 4 lines, parallel lines. In terms of FFT, why it is fast in the sense is, we are decimating in terms of time or in terms of frequency, and we are dividing the n value as 2 halves, again half and half. So that is called it as radix 2. In the procedure for finding the FFT, first we have to represent input sequence that should be in bit reversal order. So in bit reversal order, why it is bit reversal order? So before going to this, first bit reversal order, whenever, suppose if you are having 2 bits, n is equal to 2 bits, in digital electronics we can make it as 4 combinations. So this is decimal number 0, decimal number 1, decimal number 2 and decimal number 3. This is a normal order. If I take bit reversal order, it means interchanging of bits. If I change these bits, again we will get a 0. If I change 0, 1, then the reverse of 0, 1 is 1, 0. Again 1, 0, the reverse is 0, 1. 1, 1, again the reverse is 1 and 1. So this is decimal number 0 and this is the decimal number 2, then 1, it is 3. If you are identifying when we have a bit reversal pattern, so first one is we got even values and second we got odd values. So it means whenever we have 4 lines in the bit reversal pattern, first bit is x of 0 and second line input should be x of 2, third line input should be x of 1 and fourth line input should be x of 3. Now using the same procedure, the input should be in terms of bit reversal order. So first input is x of 0, then x of 2, x of 1, x of 3. Now given x of n is 0.5, 1, 0.5 and 0. Therefore, x of 0 value is 0.5, x of 1 value is 1, then 0.5 and it is x of 3 is 0. Now we have 2 stages, stage 1 and stage 2. Now first stage we will have n by 2 butterflies and second stage we will have again n by 2, n by 4 butterflies. If I have again third stage, n by 8 butterflies and so on. Now connect this first line, that is even line, with again even line. So this is called it as 2-point DFT. For 2-point DFT, so we have first stage we have only one twiddle factor, that is omega 4 power 0. Then wherever we have this twiddle factor, we have the line connected with -1. Now at this node I have 2 inputs. First input is 0.5. What is the second input? 0.5 multiplied by twiddle factor plus 0.5 into twiddle factor. So the answer is 0.5 plus 0.5 is 1, because omega 4 power 0 value is 1. And second line, again I have this node. First input is 0.5, second input is 0.5 multiplied by twiddle factor multiplied by -1. So remember, first line is addition, second line is subtraction. So 0.5 minus 0.5 is 0. Similarly, for third line, first input is 1, second input is 0. So therefore the answer is 1. Now this 1 minus 0 into twiddle factor, that is 1. So in stage 1, so why it is simple in terms of FFT is, the stage 1 output will be act as stage 2 inputs. Now at stage 2, n by 4 butterfly. What is the n value? 4. 4 by 4, 1. Only one butterfly we have. So combine this first line, even line with odd line. Again reverse for getting a butterfly. Again second line with fourth line. Again it is reverse. Now last two lines will have twiddle factor. So for stage 2, only two twiddle factors. One twiddle factor is omega 4 power 0 and second twiddle factor is omega 4 power 1. Now again I have 4 nodes to get the output. For first node, first input is 1, second input is 1 multiplied by the twiddle factor, 1 into omega 4 power 0. So 1 plus 1, that is 2. Now again for second node, first input is 0, second input is 1 multiplied by the twiddle factor, that is omega 4 power 1. What is omega 4 power 1 value? Minus j. 1 into minus j, that is minus j. Then at this node, again already we have calculated two additions. Now two subtractions with same inputs. So 1 minus 1 into omega 4 power 0, that is 0. Next one is 0 minus 1 into omega 4 power 1, that is equal to j. So therefore these are our final DFT output. The output should be collected after the line as in normal order. Now we got first x of 0 value, that is 2, x of 1 value minus j, x of 2 value, that is 0, x of 3 value plus j. So therefore the DFT output x of k is equal to 2 minus j, 0 and j. So this is about DIT FFT algorithm. Now we can write the same for programming part also. In the MATLAB programming, just we have a command called FFT. So this command will give all the output expression, output sequence using the given input sequence. Thank you.